Hi everyone, in this section, 1.4, we're going to deal with solving equations. Now I'm sure you're familiar with some of the basic equations and even some more complicated linear equations. Things like 2x minus 5 is equal to 21, for instance. In this sort of example, you're trying to isolate the x. And we know that whatever you do to one side of an equation, you can do to the other side, generally speaking. There are some principles that govern how we treat these. And so one basic one is if you add an amount to one side, you have to add the same amount to the other side to balance it out. Okay, so here, and generally we want to get, we want our final equation to just have the variable on one side and some sort of constant, you see, some sort of constant on the other side. And so that variable is really the same as 1 times the variable plus 0, okay? So x is really 1x plus 0. So I want to change the minus 5 to a 0, change the 2 to a 1 somehow that makes sense mathematically, okay? And so that's our goal. And of course, there's a lot of other things we can do if we have more than one variable in the problem, or if the variable shows up in multiple places, and a little bit more to it than that. But just for a basic one, to get the minus 5 to be 0, I've got to add 5, right? To get negative 5 up to 0. So I would add 5 to the left, but if I do that to the left, I also have to do that same thing to the right. The minus 5 plus 5 combination is 0, so I don't need it. They cancel out. The 2x is still there, though. On the right side, 21 plus 5 is 26. Then, instead of a 2x, I really only want to know what 1x is equal to. So, how do I turn a 2 into a 1? Well, I divide it by itself, right? So you divide by 2. They would cancel out. 2 divided by 2 is 1. But if I divide the left side by 2, I got to divide the right side by 2. Okay, so you divide both sides of the equation by the same thing. The 2's cancel on the left. You're left with just an x. And of course, 26 over 2 is 13. Okay. Now, one thing that's a little bit different than what you may have seen in previous courses is that we're going to represent our final answer in a form that we call a solution set, okay? A solution set. And really all it is a set that contains all the solutions to the problem, to the equation, okay? Now this works for equations only. If you're not dealing with an equation, we wouldn't have a solution set. So when we're solving equations, we use a solution set to represent the answer. And in this case, remember in section 1.1, we dealt with sets. In this case, it's the set containing just the number 13, because that's the only number that is a solution to this original equation, okay? It seems a little bit strange and maybe redundant or unnecessary to take this answer and just write it in that solution set. It seems, well, why can't I just circle the answer? And it makes sense now because it's really, they're the same thing. However, later in the course, we're going to find that there are some equations that have multiple answers, and we want to get them together in a nice compact way or representation. There are also some equations where you're going to find answers that don't actually work, or you might have 2 or 3 answers and only one of them works. And so we want to make sure to designate which ones are actually solutions and which ones aren't. So we set those aside and put them in a solution set, okay? But again, for right now, whatever we get as an answer is just going to go into the solution set.